Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Dyah Chandra from University of Indonesia. And today I would like to present my research about a system dynamics modeling on the analysis of subsidies provision in the electric bus market share. And first of all, I would like to thank to BISTEC 22 Research Excellence so that I can join this presentation in the conference. And then I also would like to my supervisor, Professor Dr. Insinyur Sutanto Suhodo, so that I can finish my research. Now let's start the presentation. This is the outline of my presentation. It consists of 5 points. The first is introduction, and then literature review, research design, result and analysis, and the last is conclusion. Let's start with the introduction. The background of acceleration, the battery-based electric motorized vehicle program in Indonesia is Indonesia now is currently accelerating the development of electric vehicles as stated in Presidential Regulation number 55 of 2019 concerning the acceleration of the battery-based electric motorized vehicle program on August 12, 2019. Issues concerning the necessity to accelerate the implementation of electric vehicle in Indonesia is motorized vehicle growth on 2006 until 2016, about 11.5% per year, based on data from Ministry of Energy and Mineral Resources, which impact on the need of fossil fuel is also increased due to the vehicle growth, and air pollution is increased along with the growth of vehicles and fuel consumption. So one of the solutions to reduce the fossil fuel need is to increase national energy security with electricity towards national energy security. But one of the barriers to implement electric vehicles is the price of electric vehicles is expensive and also need to develop new charging infrastructure. On the other hand, the acceleration to the implementation of electric vehicles in cities in Indonesia is a good opportunity to realize a better public transportation by transition of conventional buses to electric buses. This is in line with the Blue Sky program launched by the DKI Jakarta Government on 2019, with one of the strategies carried out through the use of electric-based vehicles, including for public transportation by electric buses. Based on literatures, there are many other advantages of electric buses, such as local emission-free and then low noise during operation, doesn't require any gearbox, longer lifetime, and then minimal recovery of energy use during braking, operation that occurs when braking is minimal, and also suitable as a renewable energy supply. But the transition from conventional buses to electric buses is facing some challenges, such as electric buses are 2 to 4 times more expensive than conventional buses. Electric buses also need infrastructure to support consistent charging. The electric bus battery needs to be replaced at least once during its lifetime, and the cost of replacing the battery can up to half the price of the vehicle. Electric buses have limited range, and their travel range may decrease further during operation due to decreasing battery capacity. And based on the experience of other cities in the world that have successfully implemented electric buses, for example, in Shenzhen City, there are several strategies that can be applied, such as subsidies provided by the government and a lease system to reduce investment costs, optimization of charging and operational systems, and warranty for the battery lifetime. In Indonesia, the government tried to encourage the development of electric vehicles by issuing several programs and policies, including a roadmap for land transportation using a battery-based electric bus fleet by Ministry of Transportation, and then campaign for the use of emission-free electric-based vehicles in 2019 through the Blue Sky program launched by the government of DKI Jakarta, and the DKI Government Instruction number 66 of 2019 concerning battery-based motorized air quality control. The potential for the development of electric buses as public transportation in Jakarta is basically in line with the government program. And along with the policy to promote public transport use in Jakarta, the use of electric buses is expected to allow significant results in reducing local air pollution from transportation sectors. And DKI Jakarta now is at the first stage in developing electric buses to public transportation and targeted that by 2030, all the public bus operated in Jakarta are using electrical. And this is the comparison between the number of electric and non-electric public transportation or buses in Jakarta targeted by the government by 2030. And for problem formulation and my research purposes are, first, to find out the current market share of electric buses in Jakarta, and then to identify factors that influence the market share of electric buses, to find out the current policy schemes that have been implemented by the government regarding the provision of subsidies and fare setting to support the electric bus market share. And the last is to analyze and make a system dynamics model for the development of electric buses in Jakarta by considering the policies of the government regarding the subsidy provided to accelerate the use of electric buses. And for the problem scoping and assumption, the first is the study focuses to analyze the potential market share of electric buses in Jakarta with the implementation of subsidy from government and the exemption of the electric vehicle purchase tax. Modeling is carried out for time range 2022 till 2030 with some variables using historical data from 2015. And the analysis is carried out for large type buses operating in Jakarta. Now the second part is literature review. The definition of system dynamics. System dynamics is a study of the structure and behavior of socio-technical systems to guide effective decision-making, learning, and policy of growing dynamic complexity in the world. In context of transportation systems, system dynamics modeling is very appropriate because it serves to reveal the structure of the underlying system and the dynamic transitions that arise from this structure. In studies related to the market share of electric vehicles, system dynamics is mostly used to predict future changes in the EV market share and explore key factors influencing the diffusion of EVs. There are 6 important steps in building a dynamic system model, include problem identification and definition, and the second step is system conceptualization. The third is model formulation, and then model test and evaluation and use of the model, and the last is implementation. And in general, the barriers of a city in implementing electric buses as public transportation can be categorized into three categories. That is, there are technological barriers, financial barriers, and institutional barriers. Each of these barriers can be divided into several elements. Those are vehicle and battery, the organizing operator, and then electric charging infrastructure. Some of the technology barriers are lack of information on barriers and supporting factors for e-bus implementation, and then lack of information about adopting a new operating model. And then the grid infrastructure and electric charging are new and evolving technologies that face limitations and stability challenges. For the financial barriers, difficulties in changing procurement patterns and lack of long-term and scalable financing options. And the last is no financial institution is willing to make such investment other than small-scale pilot projects. And for the institutional barriers, lack of public policy, and then there is no law or roadmap to provide a strategic plan or financial support to implement e-bus, and the lack of financial, institutional, and funding is also factors that make mass electric bus implementation is difficult. And this is the problem statement and scoping. Studies on electric vehicles that have been carried out in Indonesia generally discuss the adoption of electric vehicles for private vehicles, both electric motorcycles and electric cars. Since there has been no research related to the potential use of electric vehicles, especially buses as public transportation in the city, in this study, an analysis of electric vehicles as public transportation in Jakarta will be carried out using system dynamics modeling. This study focuses to analyze the potential market share of electric buses in Jakarta with the implementation of subsidies from the government and exemption of the electric vehicle purchase tax. System dynamics was chosen as the modeling method because the system dynamics methodology can provide a better understanding of the system structure and deduction of system behavior. And modeling is carried out for the time range from 2022 till 2030. The part 3 is research design. My research method is the study focuses to analyze the potential market share of electric bus adoption in Jakarta with the implementation of a policy of providing subsidies using system dynamics. The conceptualization model is represented as a causal loop diagram and a diagram of the system with stock and flow diagram. And the first stage of the study is identifying significant factors that influence the development of electric-based public buses in cities by doing study literature and making an interview with stakeholders. Previous studies focused on electric vehicles, electric bus market share, and system dynamics can be seen in this table. And the second stage of the study is the determination of the key variables to be used in the construction causal loop diagram. Several important key variables in the development of electric buses as public transportation are developed in a causal loop diagram that can show the interactions and interrelationships between the factors. The study chooses some key factors that influence the development of electric vehicles as public transportation, which are some of them described in this table. There are transport operator subsidy share, and then total cost of ownership, the regional revenue and expenditure budget, operational costs, investment costs, and vehicle tax. And this is a conceptual model with a causal loop diagram. The correlation between subsidy share given by the government to bus operator and the capability of the operator to provide public buses can be seen in the causal loop diagram, which is the conceptual model of the study. The total operator budget, which is obtained from revenue and subsidy from the government, should be used to non-e-bus total cost and also e-bus total cost with a negative loop, which represents a balancing loop. The capability of the operator to provide a new e-bus and convert the existing non-e-bus to an electric bus is dependent on the budget availability. And this is the model development with a stock and flow diagram. After the development of causal loop diagram, the next step of the modeling is the development of a stock and flow diagram. This stage is the development of a mathematical model or stock and flow diagram of the CLD that was previously made using dynamic system simulation software with FanSim. At this stage, changes and influences between variables can be seen in the form of mathematics or equations. And this is for the data validation. Some variables are validated based on the historical data obtained, and they will be input into the stock flow and into the stock flow diagram. Validation data is one of the ways to convince the model developed accurately represented the current state of the system by observing the relationships of the variables in the model. The variables which are validated based on the historical data are the number of bus passengers, and then the electric vehicle battery price, and then the APBD or regional revenue and expenditure budget. Historical data for the number of bus passengers is obtained from the annual data on the number of Transjakarta bus passengers from 2015 until 2021. Historical data for electric vehicle battery price is obtained from the price of electric vehicle batteries per kilowatt hour, which continues to show a downward trend since 2010. And historical data for the APBD is obtained from the annual regional revenue and expenditure budget from 2015 until 2022. Here we can see in the upper graphs, the upper graph shows the historical data. We can see that the historical data and the model built have shown the same trend. And in the lower graphs show the modeling results. The blue line shows the trend from the model built to represent the growth of the variable until 2030. And this part 4. Part 4 is the result and analysis. The proportion of e-bus and non-e-bus. This model was built using data on bus fleet ownership by the operator in 2022 with the details of 4,270 units of non-electric buses and 30 units of electric buses. The number of electric buses by 2030 is the number of electric buses which are new fleet added by the number of buses that are conversions from non-electric buses to electric buses after passing the non-electric bus operating period, which is 10 years. And it can be seen in the graph that from 2022 till 2030, the number of non-e-bus is decreased and the number of electric buses is increased, with the proportion of about 81% electric buses and 19% non-electric buses. And it means that from the result of the study, in 2030, not all public buses have been replaced with electric buses following the target set by the government for bus electrification of 100% in Jakarta by 2030. And this is the subsidies provision and operator revenue. The baseline financial support scheme used in the study is the subsidies provided by the regional government for all public transport operators in Jakarta is about 6.2 trillion rupiah. And of the total subsidies provided, subsidies for public bus operators get the largest share, reaching around 4.5 trillion rupiah for public service obligations. Besides the subsidy from the government, bus operator also get revenue from the bus operational fare. In this study, the bus fare used is fixed, but is influenced by the inflation rate. The graph shows the increasing of the bus operator income from fare box and the subsidy provision from the government during the adoption of electric buses. It can be seen that the two lines show an upward trend. The blue line represents the amount of fare box obtained by bus operators, while the red line represents the provision of subsidies provided by the government. It's also seen that the upward trend in the fare box amount is higher than the subsidies provision, where in the next few years, with the increasing of bus passengers growth, the amount of fare box obtained by the operator may be higher than the subsidy provided by the government. Now we come to the last part of my presentation, is the conclusion. Here are some conclusions obtained from my research. The first is, in the adoption of electric buses as a public transportation in a city, it is important to know the factors that support the electric buses development and also the barriers that the city has. The second is the financial barrier to invest and operate the electric buses in Jakarta is supported by the government through the provision of subsidies and also other policies that can reduce the investment cost for electric buses, including tax exemptions on the purchase of electric vehicles. And the last, from 2022 to 2030, the trend of public electric buses used are increasing and the fossil fuel buses used are decreasing. And by the end of 2030, the proportion between electric bus and fossil fuel bus almost reach the government target. And here are some references that I use in my research. Okay. That's all of my presentation. I hope it can give new information to all the audience here. I also apologize for any mistakes that I made during this presentation, and thank you.